pleasure to have you with us, and hopefully we'll see more people joining shortly. But we're going to go ahead and get started. So I am currently in Orlando at a National Facilities and Management Technology Conference. It's all about building operation and operational efficiency and how we can help building owners achieve that performance that they're after. And so timely presentation on recommissioning building systems to enhance operational and efficiency. And that's going to be led by our own Jonathan Curtin. Jonathan is a accomplished and engineer and certified energy professional, as you can see by his registrations and certifications, very much engaged in building performance associated with mechanical systems and therefore their operational efficiency. So Jonathan will do a big part of that for my role as a moderator, and I'm engaged as a service line manager nationally for Terracon. And so we're going to go ahead and get moving. We'll start this with our little bit discussion of safety, as Terracon always does. And just wanted to pass along that all of our folks, upon hiring, take this course online. It is called the Smith system, the 5 keys associated with safer driving. And think about these things. Ask everybody to think about these things when they're driving, and we all will today at some point, more than likely, or in the near future. Think about these keys to be a safer driver, to be a defensive driver, and it's great to share with your family. And this is available to anyone online. And so if you'd like to check it out or ask for more information, let us know. But it is a third-party system that really helps folks change your mindset on driving safely. So it's what Terracon folks all learn and live by, and it's been a great system for us to continue to focus on drivers, because we have probably any one time well over 2,000 to 3,000 folks on the road every day, and so it's a big part of our safety culture. Real quickly, just for those who may not know what Terracon is about, we are an engineering consultant nationally. That number is probably closer to 200 offices and well over 7,000 professionals engaged in the primary practices of geotechnical, materials testing, environmental consulting, and Jonathan and I are both in the facilities consulting division and services of our company. We've been around over 60 years. We're in our 60th year now. And for a company our size, we operate nationally, but we probably have an office and a great staff in most of the cities that anybody on this call would be on. So run nationally, but deliver services locally to our clients. And with that, we'll let Jonathan step up and engage with y'all on what y'all came to listen to. Thank you.
Good morning, good afternoon. I'm going to get right into this. Did you know that the average commercial building wastes up to 30% of the energy it consumes? And as bad as that sounds, energy is often the smallest part of that story. People are a company's largest investment, typically 10 to 100 times greater than energy costs. And even small drops in productivity from discomfort or poor air quality can easily outweigh an entire building's energy or annual energy bill. Where does this waste come from, you might ask? Most of the waste is not caused by outdated and aged equipment. It's caused by systems that are no longer tuned properly. We all have experience in buildings, and are you familiar with buildings that might have numerous hot and cold complaints, muggy conditions or condensation issues, high humidity damaging finishes or equipment, indoor air quality complaints? Those are all symptoms of systems drifting away from their original and optimal performance. The good news is that performance degradation over time is normal, and it's not permanent. There's no rule that says you can't bring your existing systems back to their optimal form. And that's exactly what recommissioning does. It's one of the most cost-effective ways to restore building performance, comfort, and reliability without replacing major equipment. So today we'll introduce the recommissioning process, explain why it's a necessary tool at our disposal for enhanced operations and efficiency. Recommissioning, as the name suggests, is simply commissioning again. Now, commissioning is a quality-focused process for ensuring that new construction achieves design intent and owner operational needs. The U.S. Green Building Council's LEED certification program helped shine a spotlight on commissioning, where it was a mandatory measure for all LEED certified projects. And it really, in the 2000s was when LEED really started to take off. And then later, with the adoption by many states of the 2015 International Energy Conservation Code, commissioning has become more of a standard construction requirement for the majority of new construction projects, or at least all but very small buildings. And with or without LEED certification pursuits. Now, when commissioning is done right, buildings perform very well right from day one. But with time, as operations change and components age and schedules drift, performance inevitably starts to slide. So think of a world-class athlete who once performed at the top of their game. After years of strain and chronic injuries and time away from peak training, their performance declines. But because their foundation is strong, with targeted retraining and recovery, and maybe a little inspirational theme music, they can return to elite form. And that's recommissioning. It's bringing a building back to its intended performance level efficiently, effectively, and without having to knock down the building and start all over. So recommissioning sits alongside several related programs, and they're all focused on optimizing existing building systems. Together, they are often grouped under the umbrella of existing building commissioning. And while some practitioners might draw real clear distinctions between using the different terminologies, others might use them interchangeably. So to just give a brief introduction of these other terms, there's retro commissioning, which is applied to buildings that were not previously commissioned. There's ongoing commissioning, which is a continuation of the commissioning process, and that's either following new construction or a or retro commissioning effort, and that continues through occupancy and operations. There's monitoring-based commissioning, which is an ongoing commissioning approach that leverages data analytics and system monitoring to identify and resolve performance issues. And there's continuous commissioning, which is actually a registered trademark by Texas A&M Energy Systems Lab. And I have a number of mentors up there who kind of came through that program. And yeah, it's focused on continuous optimization of comfort and and energy performance. So regardless of the terminology, all of these programs share a common goal, and it's about restoring and sustaining building performance for comfort, efficiency, and reliability in existing buildings. You might ask, why does recommissioning matter? Well, people want to work and learn and live in buildings that perform well, comfortable, healthy, and efficient spaces. Remember, the largest cost inside the walls of a building are its people. It's not energy. Even small losses in comfort and air quality can reduce productivity far more than the value of energy savings alone. So recommissioning is one of the most cost-effective ways to improve occupant satisfaction and comfort, to restore optimal system operation and reduce wasted energy. It's a hedge against future energy price increases, especially in this world with the rise of AI and trends in electrification. It delivers comfortable, efficient buildings that keep tenants and staff happy. Recommissioning also helps ensure that units run only as needed, reducing runtime, wear, maintenance, and extending equipment life. It supports sustainability goals, whether self-imposed or driven by local energy or climate policies. Note that the lasting performance of recommissioning depends on operator engagement. Training the O&M team, helping them understand optimal control settings, identified issues, and implemented improvements is essential for sustaining the long-term benefits of recommissioning. We're going to go through the steps of the process now in a bit more detail. So recommissioning follows a 5-step process that begins with planning and assessment, moves through investigation and implementation, and concludes with turnover and ongoing performance verification to ensure lasting results. The planning and assessment phase sets the foundation for a successful recommissioning effort. This is where we take the time to understand the unique owner goals, whether that's energy savings or improved comfort or staff training or meeting sustainability targets. Every project's a little bit different, and clarity here defines success later on. We then bring together the right team. It's not just the commissioning provider, but it's also the operations staff, it's controls technicians, and the contractors, mechanical, electrical, test and balance, who know the systems best and are needed to implement the fixes. From there, we identify what buildings are best candidates for recommissioning if it hasn't already been done by the owner. And it's typically those with high energy use, comfort complaints. It could be there's a high degree of staff turnover on the O&M side. Typically buildings with a minimum area of between 50 and 100,000 square feet is generally kind of the target size for those size buildings and above for the application of recommissioning. But that's not to say that smaller size buildings wouldn't benefit, but would be slightly less cost effective in doing so. Sometimes even a well-built building can fall out of tune simply because people or priorities have changed. You know, finally, in this phase, we review any existing documentation, past commissioning reports, control sequences, test results, and we start developing the recommissioning plan. That plan defines scope, responsibilities, communication, and how the investigation and testing will be carried out. This step builds alignment across everybody involved on the team and ensures the process starts off on the right foot. Once we finish planning and assessment, the investigation phase is where we really start to get our hands dirty and to see what's going on in the building day to day. This is when we dig into trend data, analyze utility bills, run functional tests of equipment to see how systems are actually performing. We're often uncovering those hidden inefficiencies that quietly eat away at comfort and energy performance. Things like miscalibrated sensors, control issues, or failed components of a system. From there, we outline practical, prioritized fixes, starting with low cost or no cost operational adjustments that deliver quick wins. This phase really connects the dots between identifying problems and setting the stage for measurable, lasting improvement. The implementation and verification phase is really where the results start to show. It's about turning the investigation findings into real system changes, tuning controls, correcting issues, verifying everything through testing and trending, and making sure the O&M team understands what's been done so performance can persist. The turnover phase is about handing back the building that's performing at its best and making sure the operations team has everything they need to keep it that way. It's also where we close the communication loop with documentation, training, and performance verification. The ongoing commissioning or persistence phase is really about protecting the investment made through the recommissioning process. Buildings don't stay perfectly tuned forever. People make changes, controls get overridden, schedules drift. So this step is about making sure performance doesn't quickly slide back right to where it started prior to the process. In this phase, we set up regular reviews of system trends and key performance indicators. Many owners now use analytics, dashboards, or automated fault detection tools that flag issues before they turn into bigger problems. Periodic functional testing and data reviews help catch small drifts early when they're easy and inexpensive to fix. Equally important, we keep the O&M staff engaged, reviewing trends together, reinforcing training, and maintaining awareness of optimal system configurations. Ultimately, this phase is about persistence. We're not just fixing the issue once. We're building a framework for continuous improvement, keeping comfort high, energy waste low, and the building operating at its best, hopefully for years to come. Common findings. When we start digging into a building, the biggest opportunities we uncover usually aren't from major equipment failures. They're from smaller component issues that have ripple effects through how the systems interact. We often see systems heating and cooling at the same time, or controls overridden to get through a day or a short period or to temporarily solve a problem, and then they're never restored back to their automatic mode. Sensors drift out of calibration, dampers leak, and schedules fall out of sync, leading to air being conditioned or lights being on in spaces that don't need it. Sometimes ventilation systems are out of balance or humidity control sequences are poorly configured. Even well-intentioned efficiency measures can end up being disabled because when misconfigured, they're causing comfort complaints. The point is, none of these systems are none of these problems are unusual, and nearly all of them are fixable through the recommissioning process. These small operational gaps add up, often compounding across systems, and closing them, we can unlock major improvements in comfort, air quality, and energy performance without replacing a single piece of major equipment. Here we're going to talk about a case study, which is a 60,000 square foot laboratory building in Texas that was constructed in 2017, but when it was ultimately commissioned, it was 2018. We were called in to investigate due to persistent operational issues as early as 2022. So that's not even 4 years into the building operation. And what we found were poor pressure controls created by an issue where chemical process odors were migrating outside of the laboratory space and into the adjacent administrative spaces of the building. Numerous factors contributed to that problem, including a large return air fire damper that was found closed, leaking hot water valves, creating very high cooling airflows, pressure sensors that were in need of calibration, a failed exhaust flow sensor, a failed air valve actuator, and the start and end of day ramp up and shut down control sequencing of these large exhaust and makeup air systems would over and undershoot set point and were slow to stabilize their controls. The chillers were found to be short cycling. There were 2 chillers that would run for less than 15 minutes. These are water cooled chillers, and then shut off abruptly while the other one would take over the load, but then it would call for the second chiller to come back on again. The air handling, and they couldn't maintain a consistent chilled water supply temperature. The air handling units with a large volume of outside air, this being a laboratory building, were not consistently wringing the moisture out of the air as they should because of the inconsistency of the temperature supplied by the chilled water system. This example, this case study really demonstrates how some buildings can really quickly deteriorate, post new construction and initial commissioning. One of the major lessons, and probably the biggest lessons learned by the recommissioning team and the building owners, was that the process was that the O&M staff assigned to care for the building was woefully unprepared and understaffed for the complexity of the building and the volume of regular preventive maintenance and repair work that the building required. So the owner ended up working to contract externally with a third party to perform that regular PM and repair work. Next few slides are going to show some of the trended performance we saw through our process and some of the improvements. This shows chilled water temperature before and after our initial diagnostics and preliminary attempts to resolve the issue. You could see the wild instability on the left and the relative stability after the change was implemented. Here is an air terminal unit with hot water, heat, and cooling airflow provided by an air handling unit. The space this unit serves is warm relative to what it should be. The space temperature is 73.5 degrees and the cooling set point is 72 degrees. Air from the air handling units entering the unit at 52 degrees, nice and cool, but it's leaving at 73 degrees. However, the controls are calling for no heat. So it's the temperature gain across that heating coil is 20 degrees and it's not supposed to be heating. The supply air damper is opening close to its maximum position and it's going to continue to open. It's already at 93% and it's trying to increase the supply of cold air to overcome that heating load. So this is a common example of the simultaneous heating and cooling we often see and experience with these type of projects. Here's a chart of monitored exhaust duct pressure. The pressure spikes circled in red on the left of the chart are related to time periods where either the building is beginning to start operations for the day, where there's a kind of a short and sudden increased need for a higher volume of exhaust and makeup air supplied to the laboratory, or at the end of the day when those large volume fan systems start to reduce flow down to their minimums. The control sequences governing the timing of the damper movements and variable fan speed controllers made the system overshoot the duct pressure set points and then undershoot in trying to respond quickly. And it would take a significant extended period of time to settle out. And during this period, the pressure difference between the laboratory space and the adjacent administrative spaces in the building were all out of control. So after a period of some testing and tuning, the chart can be seen as circled in green to still have some spikes at these these startup and shutdown periods, coinciding with the exhaust and then the change in volume needs. But the amplitude of those changes and the duration and the speed at which they kind of settle around set point has been greatly enhanced. Cost savings and ROI. When we talk about costs for recommissioning, it's important to put things in perspective. There are some industry studies, including those from Lawrence Berkeley National Labs and ASHRAE, showing that costs can typically range between 25 to 60 cents per square foot. Again, this depends on the complexity of the buildings and the level of testing. Larger and more complex high-end facilities, hospitals, labs, and large campuses might run a bit higher. while simpler office and education buildings often fall towards the lower end of that range. The real story, though, is on the returns. On average, payback periods are typically less than about 3 years, with verified energy savings typically in the 5 to 15% or more range. And that's before accounting for the improvements to comfort, reliability, and system longevity that often accompany recommissioning. It's also worth noting that many utility providers offer incentive programs that help offset costs of recommissioning or building tune-up projects. And these can cover anywhere between 25 to 75% of eligible costs, and often include technical assistance or data analysis support. So when you combine the incentives, the operational savings, and the avoided maintenance issues, recommissioning ends up being one of the most cost-effective strategies available for improving building performance. Building resilience and future-proofing. One of the lesser talked about benefits of recommissioning is how much it contributes to a building's overall resilience and readiness for the future. Through the process, we're not just improving efficiency, we're finding the weak points before they become failures. These can be things like control sequences that don't respond well to weather swings or extreme weather events, or equipment that isn't performing safely or as safely or reliably as intended. Recommissioning also helps buildings adapt to change, like hybrid work schedules or increased ventilation requirements for indoor air quality. It plays a direct role in supporting decarbonization and load management goals, helping the facility operate flexibly as energy systems evolve. By restoring optimal performance, we extend the life of equipment and reduce the risk of costly breakdowns. And in some cases, we even verify how critical systems would respond during disruptions, ensuring that the building, its equipment, and occupants are protected from these outside shocks. Here are some tips for making recommissioning successful. Launching a successful project starts with screening your buildings. Focus on facilities with high energy use. Benchmark your buildings using Energy Star Portfolio Manager. Look for buildings with reoccurring comfort complaints or with modern but poorly performing controls. Buildings that have experienced occupancy or scheduling changes since the pandemic are also potentially good candidates. Utility programs can often help with screening tools and benchmarking support. Next, select a qualified and trusted provider. Look for commissioning authorities or firms that have proven experience, ideally independent from vendors, to ensure objective recommendations. Budgeting wisely is key. So plan for both investigations and implementation costs. Typically, we said in the range of 30 to 60 cents per square foot, plus a modest contingency, maybe 25% of the total for adjustments and repairs. Many utilities offer incentives that can offset much of those costs up front. From there, set realistic goals and timelines so that the process Generally takes about 3 to 6 months for investigation. And this again can vary widely from building to building, and maybe 12 to 6 months or 6 to 12 months for implementation and verification. So establish measurable success metrics such as 10% reduction in energy use or improved comfort scores, and assign an internal champion to keep the effort moving. Throughout the process, engage your operations staff early. Their familiarity with systems makes their input invaluable, and their involvement in training and testing ensures that changes last longer after turnover. Finally, leverage data and persistence. Use trending tools or dashboards to verify sustained performance, and consider ongoing or monitoring-based commissioning for continuous improvement. Treat recommissioning not as a one-time project, but as part of a reoccurring maintenance and optimization cycle. Ultimately, position recommissioning as a risk management strategy. It's not just about energy savings. It's about protecting your assets, improving reliability, and maintaining comfort and satisfaction for occupants and operators alike. Sorry for the slide trouble. For some key takeaways, buildings are a lot like cars. When you first buy one, everything runs smoothly. The engine hums, the alignment's perfect, and fuel efficiency is right where it should be. But over time, things drift. The tires wear unevenly, filters get clogged, and maybe a warning light pops up that everybody ignores for a while or disables. The car gets you where you need to go, but it's using more gas, it's running rougher, and probably costing you more in the long run. That's exactly what happens to buildings. Even the best designed systems fall out of tune. Sensors drift, schedules get overridden, and equipment starts working against itself. Recommissioning is the building's tune-up. It doesn't replace the engine. It cleans the filters, checks the timing, resets the alignment, and restores performance to where it's supposed to be. And just like with cars, if you do regular tune-ups, your building lasts longer, it runs more efficiently, and avoids those costly breakdowns that happen when things are ignored for too long. And that concludes my presentation for today. And
Great, Jonathan. I really appreciate your key takeaways. I think for anybody that's considering the need, these takeaways are just what you need to get the process and the effort approved, maybe some funding for this, because, and I appreciate your analogy of it's like a car, and a lot of equipment we have, it has to be maintained if you want it to keep performing well and at optimum performance. So I think that's really, really important. One question I had for you is, we hear a lot about energy audits, right? And the utilities are offering energy audits and as a step. Why do we have an energy audit process and a recommissioning process, or what's the difference?
well, the main difference between the two is the implementation phase of retro commissioning. And so this process takes it a bit further than just the energy audit. And it's actually one of the the things that make the or retro commissioning so challenging is to not only to identify the issues, but to find the time and the wherewithal and to schedule, to get shutdowns where needed, to take care of those deficiencies and get them addressed. So that's where it goes beyond just the identification of the issues, which typically is the focus of energy audits.
Very good. And then, of course, the challenge of stepping into the process. You mentioned anywhere from 3 to 6 months. Is that pretty typical in terms of, you know, getting somebody on board to run through a recommissioning and results, or can you talk a little bit more detail there?
Yeah, great questions. It really hinges highly on the team and the owner and operational staff needs and desires. Of course, with any of these projects, as the duration lengthens, it becomes more and more challenging to get things done. And so anything that can be done to compress that timeline and keep all the team members engaged and immediately moving from phase to phase and making things happen on a shorter period, it's beneficial to the project and it's better for demonstrating results. But in reality, it takes time to, particularly for the implementation phases, depending on what fixes need to get done, who needs to be a part of it, and when and where it can happen. It does take some time, so you have to be prepared going into the process, knowing that you know, it could be up to a year.
That's understood. Very good, Jonathan. Thanks. I don't see any other questions. If anybody has any, please drop them. But if not, Jonathan, thanks. That's very informative, very thorough, and I think the key points, the key takeaways, and description of the process were very, very strong. So appreciate that. And with that, we will end the presentation and let y'all return to your days. Thanks.
Thank you very much.